So today's notes are more on linear functions. It's going to be chapter 2, section 4. We've skipped to 3. Our content objective is going to be to write an equation of a line given its slope and a point on the line. And our language objective is going to be to define slope-intercept, point slope, and standard form. So those are 3 different ways that we can write equations of lines or write linear function equations. So we're going to review them. We've already talked about slope-intercept forms, so I'm going to jump in and make a quick table with these different forms. Starting with slope-intercept form, which we know is y equals mx plus b. And this is going to be most useful to use when we know the slope and the y-intercept. So this is going to be most useful to use when we know the slope and y-intercept. And this is compared to point slope form, which is y minus y1 is equal to m times x minus x1. And this equation is actually just rearranging our slope formula. So if you want to try to prove that on your own by rearranging the slope formula, I'll give you an extra credit point or 2. Or we can go over it in class, but this is really just a variation of our slope formula. And it's going to be very useful when you know the slope and a point on the line. Or when you know 2 points on the line. So we again know how to find our slope when we have 2 points on the line, as we practiced last class. But we would be able to derive slope and then have a point on the line. So it's going to be useful in both those scenarios because when we have 2 points, we can derive the slope on our own. The last form I want to talk about briefly is standard form. And there's no like one instance that this is going to be most useful, but it is an equation you should know. Ax plus by equals c. We'll talk about a lot of different functions standard form throughout the year. So this is starting with linear functions, the standard form of a linear function. And it's important to know that a, b, and c are real numbers. And a and b cannot both be 0. So if they both were 0, we just have 0 equals c. That's not a thing, not an equation. So a and b cannot both be 0 if it is indeed a linear function. So those are the 3 forms that we're going to be working with lines, or the 3 forms for lines that we're going to be working with. We've already used slope-intercept, and we'll have examples where we use both point slope and standard in the notes today. So make sure you take note of these and write down any questions you have about them. So we're going to start with point slope form. And again, this is y minus y1 equals m times x minus x1. And the example we're going to use is asks us to write an equation for the line that passes through (3, 2) and 5, 8. So we're going to write the equation of a line that passes through those 2 points. As we know from the table note, we use the point slope when we have 2 points on the line, or the slope and a point. So we're going to start by solving for slope. And we know how to do this. We do y2 minus y1 over x2 minus x1. So again, y2 we'll say is 8 minus y1 is 2 over x2, which is 5, minus x1, which is 3. If it helps you, you can pull those out, label them, and then write them in. We have 5 and 8 there, 3 and 2 there, so we're all set. So 8 minus 2 is 6, 5 minus 3 is 2, so we have 6 over 2, which simplifies to 3. We know our slope, m, is 3. Now it's just a matter of substituting into our point slope formula. And I'm going to make a note here. You can choose either point to substitute in. So I'm going to give you the two possible equations for this line that given the 2 points that we have. So we can do y minus, we'll use our first one here. So y minus 2 is equal to 3 times x minus 3. So that is our first possible equation in point slope form. Or we could do y minus 8 is equal to 3 times x minus 5. So notice you can choose either point to substitute in for the y1 and x1 values as long as they're from the same point. So either of those would work, and that would be our solution. All right, make sure you write down any questions on this. I'm going to flip the page and start talking about some intercept stuff. All right, so now we're going to talk about solving for intercepts, and this is going to be important for not just linear functions, but all the functions we talk about when you're solving for the x and y intercepts. So as a reminder, the y-intercept is when it crosses the y-axis. The x-intercept is when it crosses the x-axis. So I'm just going to quickly draw. Here's our y-axis. Here's our x-axis. If we had a linear function that went something like this, then that point where it crosses the y-axis is our y-intercept, which I will abbreviate. The point where it crosses the x-axis is our x-intercept. So the key points here, when you're solving for the x-intercept, by substituting y equals 0, or plugging in 0 for y. So when I know my x-intercept, see how this is my y-axis, and I know all the y's up here are positive, all the y's down here are negative. The x-axis cuts that right in half, so the x-axis is where y equals 0. So all along the x-axis, y has to equal 0. So I know whenever I'm solving for the x-intercept, I can substitute 0 for y and get my x value. Similarly, you will do the same for the y-intercept with x. You solve for the y-intercept by substituting x equals 0. So again, all the x's this side are positive, all the x's this side are negative. The y-axis cuts that in half, so it's going to be where x is equal to 0. So all along the y-axis, x is equal to 0. So to solve for the y-intercept, I plug in 0 for x. So let's actually see how that can help us in problems with linear functions with an example. So I'm going to ask us, what are the intercepts of the linear equation 3x plus 5y equals 15? So this is an equation in standard form, and they're asking for our intercepts. So first step I'm going to do, substitute y equals 0 to solve for x. So I'm going to take 3x plus 5 times 0 equals 15. So again, I've just substituted 0 for y to get my x-intercept. 5 times 0 is 0, so I'm left with 3x is equal to 15. I divide by 3, and x is equal to 5. So my x-intercept, I know I just solved for the x value, which is 5, and I know the y value at my x-intercept will always be 0, so my x-intercept is at 5, 0. So there's my first intercept. So the second step I did was solve. Now I'm going to solve or substitute x equals 0 to solve for my y-intercept. And then I'm going to solve that out. So now I have 3 times 0, since I'm substituting 0 for x, plus 5y is equal to 15. 3 times 0 is 0, so I'm left with 5y is equal to 15. I divide by 5, and I get y is equal to 3. So then I know my y-intercept. Again, I know my x value is 0, since that's what I substitute in. It's always going to be 0 at my y-intercept. And I just solve for y, which is 3. So there's my y-intercept. And that's all we have to do. So make sure you write down any questions, comments, or concerns you have on that process. I'm going to flip the page. If you have more room than I do, by all means, you can keep writing on the same page. I just want to make sure I have plenty of space. So the last thing we're going to talk about today is parallel and perpendicular lines. All right, so parallel and perpendicular lines. We'll start by talking about parallel. We'll make a little table again. So parallel lines, they have slopes that are equal. So when you have two parallel lines, it means that their slopes are the same or their slopes are equal. So we'll draw a little visual of that for you. This is my x-axis, this is my y. It could look something like this, so I'm going to draw this so I can draw it as parallel as possible. So these are not actually perfectly parallel, but they should have the exact same slope going in the same direction, two lines. So if we said this is y equals m1x plus b1, this would be y equals m2x plus b2. So if my slopes are indeed equal, I would know that m1 is equal to m2 because they should have the same slope. The only other bit of information you should know about parallel lines is that their y-intercepts, so b1 and b2, cannot be equal. So they cannot equal each other because then they would just be the same line. So if they have the same slope and the same y-intercept, they're actually just the same line. They're not parallel, they're the same. So if we have parallel lines, their y-intercepts can't be equal, but their slopes will always be. All right, so then we have perpendicular lines. Perpendicular lines are negative reciprocals of each other. So their slopes are negative reciprocals of one another. Another important tidbit of information is not only are perpendicular line slopes negative reciprocals, but they intersect at 90-degree angles. So say I had a line like this, the perpendicular one would intersect it at a 90-degree angle. So again, not perfect, but bear with me. You know they intersect at a 90-degree angle. They are exact sort of opposite slopes in a way. So if this was y equals m1x plus b1, this would be y equals m2x plus b2. So if those are my two lines, if they are negative, if the slopes are negative reciprocals of one another, I know m1 times m2 will equal -1. So I know if they're negative reciprocals, when I multiply their slopes, I should get -1. So if I rearrange that formula, I could also say that the slope of m1 will just be -1 over m2, or similarly m2 is equal to -1 over m1. So just by rearranging that equation, now you have a way to get the other line's slope if you know they're perpendicular, given these formulas. So you know you can just flip it under 1 and negate it, and that will give you your perpendicular slope. So in case that's a little confusing, let's do an example. So, sorry, we're going to write the equation of the line that is perpendicular to y equals -4x plus 2 over 3 and goes through the point (8, 5) in slope-intercept form. So we're going to write the perpendicular line equation that goes through that point. So the first thing I'm going to do is determine my slope. So if this is the original slope, I know I can flip and negate it, and that will give me the perpendicular slope. So I know that my new slope is going to be -1 over my original slope, -4. So -1 over -4, which then simplifies to +1/4. So my new slope is going to be +1/4. And now I can plug in or substitute in point slope form. So now that I have my slope, we're going to go back to our point slope form and use the point that we're given. So I know y minus 5 is equal to 1/4 my m times x minus my x value was 8. So I have y minus 5 equals 1/4 x minus 8. And I'm going to isolate y and then write this in slope-intercept form. So to do that, I'm going to distribute and then add 5 to both sides. So again, now actually doing it, 1/4 I'm going to distribute in, so I'm left with y minus 5 is equal to 1/4 x minus 1/4 times 8 is the same as 8 divided by 4, which is 2. And then I'm going to add 5 to both sides, so I'm left with y is equal to 1/4 x. Negative 2 plus 5 is going to be plus 3. And that is my slope-intercept form. All right, make sure you write down any questions, comments, concerns you have on these notes so we can go over them together in class.